Hello everyone, in the previous video we started exercise 8.3 of trigonometry of class 10th from NCERT, and in that we discussed the solutions of question number 1 to question number 3. In this video we will continue the same exercise and discuss the solution of the parts of question number 4. In that we have been given different identities which are to be proved by applying the basic identities, the fundamental identities, since it is given that the angles which have been used or which have been given in the expressions are all acute angles. The first part in that is prove that the whole square of cosec theta minus cot theta is equal to 1 minus cos theta upon 1 plus cos theta. In proving this type of identities, either we start the problem from the left hand side or from the right hand side, and we obtain the other side by applying the basic or fundamental identities. Here we will start with the left hand side, and the left hand side is whole square of cosec theta minus cot theta. Then we have to see what we want in the right hand side. Right hand side is in terms of cos theta. Can we convert this into cos theta? Yes, if we convert them in terms of sine and cos, or we express them in terms of sine and cos, we can obtain this part. We know that cosec theta is 1 upon sine theta. And also we know that cot theta is cos theta upon sine theta. So we apply it here, cos theta upon sine theta, the whole square of this. If we take the LCM here, sine theta, then the numerator will be 1 minus cos theta, the whole square of this. The numerator is the square of 1 minus cos theta, and the denominator the square of sin theta, which we can write as sin square theta. And since we want the answer in terms of cos theta, we can convert this sin square theta in terms of cos theta. That is, we have the identity sin square theta is equal to 1 minus cos square theta. If we apply that here, we will get 1 minus cos theta whole square in the numerator, and denominator we will have 1 minus cos square theta. We also know the algebraic identity a square minus b square is equal to a plus b into a minus b. Applying that here in the denominator, will we get 1 minus cos theta whole square, and here it is 1 minus cos theta into 1 plus cos theta, or 1 plus cos theta into 1 minus cos theta. The product is to be same. Can we cancel this whole square by this 1 minus cos theta? This will cancel. And we are getting here 1 minus cos theta upon 1 plus cos theta, which is our right hand side. It means from the left hand side we have obtained the right hand side which we wanted to prove. So we write therefore LHS is equal to RHS, means left hand side is equal to right hand side, hence proved. This way we can prove the identities by applying the basic or fundamental identities. The second part here is prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 sec A. Here also we start with the left hand side. This is cos A upon 1 plus sin A plus 1 plus sin A upon cos A. If we take the LCM here, that will be 1 plus sin A into cos A. So it is 1 plus sin A into cos A. In the numerator we will have cos A into cos A is cos square A, plus 1 plus sin A into 1 plus sin A is whole square of 1 plus sin A. If we simplify this, we are getting cos square A plus we know whole square of A plus B. A square plus 2AB plus B square. We get here 1 plus 2 sin A plus sin square A. Denominator is same, 1 plus sin A into cos A. Now we know if we combine this sin square and cos square A, the identity is sin square A plus cos square A is equal to 1. If we want to apply that here, we will bring this sin square A near to cos square A. So we write cos square A plus sin square A plus 1 plus 2 sin A whole upon 1 plus sin A into cos A. This cos square A plus sin square A is 1. So this is 1 plus 2 sin A upon 1 plus sin A into cos A. 1 plus 1 is 2. 2 plus 2 sin A upon 1 plus sin A into cos A. If we take 2 common here, this will be 1 plus sin A. And here we have 1 plus sin A into cos A. 1 plus sin A and 1 plus sin A cancel. Are we left with 2 into 1 upon cos A? And we know that 1 upon cos A is equal to sec A. So we can write this as 2 into sec A, which is the right hand side. And therefore, left hand side is equal to right hand side, hence proved. The third part here is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta into cosec theta. To prove this, when we start from the left hand side, either we convert them into sin theta and cos theta, or we can convert both in terms of tan theta. Suppose we convert them in terms of tan theta, then the left hand side will become tan theta upon, we know it is 1 upon tan theta, cot theta is 1 upon tan theta. Here we can write this as 1 upon tan theta whole upon 1 minus tan theta. And we can write the reason, since we know that cot theta is equal to 1 upon tan theta. Simplifying this, if we take the LCM here tan theta and carry this here, this will be tan square theta upon tan theta minus 1. Here also we can bring this tan theta here in the denominator, and this will be plus 1 upon tan theta, and if we take this minus common from this, then this will be tan theta minus 1 here also. Why we have taken this minus common here? Because here it is tan theta minus 1. If we take minus common here also, then here also we will have tan theta minus 1, which will make it easy to take the LCM. Now the LCM we can take here is tan theta minus 1 into tan theta. So this will be tan theta into tan theta minus 1. And here we will find this will be tan cube theta minus, because plus into minus will become minus. Here it is 1. And we know the algebraic identity a cube minus b cube is a minus b into a square plus ab plus b square. If we apply this here in the numerator, because this is tan cube theta means cube of tan theta, and this is 1 means cube of 1. So will we get here tan theta minus 1 a minus b into a square means tan square theta plus a into b, that is tan theta, because tan theta into 1 is tan theta, and plus square of b, that is square of 1, it is 1, whole upon tan theta into tan theta minus 1. Tan theta minus 1 and tan theta minus 1 cancel. And if we divide each part by tan theta here, we are getting tan square theta upon tan theta is tan theta, plus tan theta upon tan theta is 1, plus 1 upon tan theta is cot theta. Now look at the right hand side, we want 1 here, so 1 we will keep at first. Tan theta is sin theta upon cos theta, and cot theta is cos theta upon sin theta. If we take the LCM here in the second and third part, will it be 1 plus cos theta into sin theta is the LCM. This will be sin theta into sin theta as sin square theta. Cos theta into cos theta as cos square theta. And we know that sin square theta plus cos square theta is 1. If we apply that here, will we get 1 plus 1 upon cos theta into sin theta? And we know 1 upon cos theta is sec theta, 1 upon sin theta is cosec theta, which is the right hand side now. This implies that LHS or left hand side is equal to RHS or right hand side, hence proved. This is the solution of the third problem. The fourth part here is 1 plus sec A upon sec A equal to sin square A upon 1 minus cos A. To prove this, we can apply two different methods. The first one here is, if we start with the left hand side, that is 1 plus sec A upon sec A. We know that sec A is equal to 1 upon cos A. If we apply that here, we can write this as 1 upon cos A plus 1 upon 1 upon cos A. If we take the LCM, this will be cos A as the LCM in the numerator. And here it is cos A plus 1 whole upon 1 upon cos A. We can see that cos A and cos A cancel. So we are left with here cos A plus 1. Suppose we write this as 1. Since we want 1 minus cos A in the denominator, if we multiply and divide it by 1 minus cos A, we will get here 1 plus cos A upon 1 minus cos A into 1 minus cos A. We know A plus B into A minus B is A square minus B square. Applying that, we will be getting here 1 minus cos square A upon 1 minus cos A. And we also know that 1 minus cos square A is sin square A. So this is sin square A upon 1 minus cos A, which is the right hand side. In the second method, what we will do, we will continue it in the same way in the first part up to 1. We have shown that left hand side is equal to 1 plus cos A. Now we start with the right hand side. That is sin square A upon 1 minus cos A. And as we know that sin square A is 1 minus cos square A, we can apply it here 1 minus cos square A upon 1 minus cos A. Now we know 1 minus cos square A can be split into two different factors. That is A square minus B square equal to A plus B into A minus B can be applied. And by that we get here 1 minus cos A into 1 plus cos A whole upon 1 minus cos A. This 1 minus cos A and 1 minus cos A cancel. And we are left with 1 plus cos A, which we have obtained in first part. And hence we can write, therefore left hand side is equal to right hand side, hence proved. Like this particular problem can be solved in two different methods. In the first one, we are taking only the left hand side and proving the right hand side. In the second method, what we do, we simplify the left hand side and also the right hand side, and we show that both are equal. The remaining parts of this we will continue in the next video. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.